So the first thing we do when we get a word is we make sure we rewrite it stacking letters. R, K, right? So no restrictions. How many letters are in aardvark? 8 factorial, and then I have to remember 2. Divide by 3 factorial, 2 factorial, and what do I get? Don't all answer at once. Remember fast answering.
3,360.
2360? Is that what you said?
No, 3,360.
Oh. Okay, the next one says the word begins and ends with a consonant. Make sure you have the dots. Multiplication. There are 1, 2, 3, 4, 5 consonants, so it begins with a consonant. Keep one there, 4. And then I have 6 letters left. 6, 5, 4, 3, 2, 1. And what do I get? $100. This one, the vowels must be together. There are 3 vowels. I hook them together. 3, 2, 1. And then I have 5, 4, 3, 2, 1. And if I said together at the front, that would be it. Correct? Because it said together, what do I have to still multiply by? 6. It's always one more than the hook together number. And when I do this, I should get 360, I believe. Okay, now if it says the vowels can't be together, whenever we see can't be together, we always say total minus them together, correct? We have both numbers. The total no restrictions is 3,360. Of all of those words, 360 of them have vowels together. So 300 of them, or sorry, 3,000 of them have vowels not together. This one says a committee of 15 people with 11 boys and 4 girls. So we have to watch ourselves. There's no restrictions. We're using the 15. If they talk about boys and girls, we're using the 11 and 4. If we're choosing boys from boys and girls from girls and they don't have any jobs, it's a C. Correct? It's like I said, principals from principals, students from students, drivers from drivers, irons from irons, right? Doesn't matter what it is. So here, we have to pick a 5-person subcommittee. So every subcommittee has to have 5 people. And then I say, are there jobs? No. So no restrictions, 15C5. And what do we get?
3,003.
2003. And then exactly 2 girls means I need 2 girls and 3 boys. Right? Because you always have to have 5. We have to watch to make sure we supplement. So girls, we have 4, choose 2. And means I multiply because and add do not go together, right? And then boys, we have 11, choose 3. And what do we get? 990? Okay, at most 2 boys means 2 boys or less. So I could have 2 boys, or, which is a plus sign, 1 boy, or, which is a plus sign, no boys. Then I have to supplement. So I have ands in here, which are multiplies. 3 girls, and 4 girls, and 5 girls. What's the problem with this? There's only 4 girls, so that case gets kicked out. So I still do the same thing. 11 choose 2 times 4 choose 3 plus 11 choose 1 times 4 choose 4. Now, if you mix up the plus and the multiplications, the answer will be there. It's common in, right? So you have to make sure that when it's an and, you multiply. When it's an or, you add. So cases are always added. This case or, this case or, this case. And what do we get for an answer? Don't all speak at once. What did you get for C?
231.
231. At least 3 girls means 3 girls or more. So I get 3 girls or 4 girls. Wait a second. This is the exact same as this. It's the exact same. I should get 231. All the subcommittee members have different jobs. If you have different jobs, then order matters, correct? So that's when we're going to get 15P5, which is what answer?
62,360.
The next one, we have a baseball tournament. There are 15 teams. How many different games will be played if everyone plays each other once? How many teams play at a time when you play baseball? Two. Does the order matter? No. If order mattered, it wouldn't be playing once. You'd be playing twice, right? So we're going to go 15C2. If they play twice, we just go 15C2 times 2. If they play 3 times, we go 15C2 times 3. Now for twice, we could also say 15P2 because then we would say order matters. These are actually the same. 15C2 times 2 equals 15P2. However, 15P2 only works when it's like even numbers of games. So I always just do 15C2 and then multiply by how many times you play each other. The next one has a circle has 8 dots on the outside edge. 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter where they are, right? And how many different triangles can be made using the circle as vertices? So how many of those vertices do we need to make a triangle? 3. Does the order matter? If I go like this, or I go like this, or I go like this, would that change my triangle? So does order matter? No, so we're just going to go 8C3. Okay, the next one says, and make sure you get answers on the test. I'm just not waiting for your answers because you're taking too long to answer. So I'm leaving them at 6. Make sure on a test you work them down. I'll have people leave them as 8C3. No, I need an answer. Okay? Unless it's a multiple choice and the answer is 8C3. In a room there are 20 people. Everyone must shake hands with everyone else once. How many people shake hands at a time? 2. Does order matter when your hands come together? Does it make a different handshake? No. So we're going to do 20C2. Anyone get the answer to that? 990? 190? Okay, this one says that using a standard deck of 52 playing cards where 5 card hands are dealt, determine how many hands contain 2 queens. Still a 5 card hand. And cards are always what? Combinations. So we need 2 queens, and we need to supplement 2 queens and 3 not queens. We always supplement with the opposite. How many queens are there? 4, and I'm going to choose 2. And how many not queens are there? Yeah, you go 52 minus however many queens there are, right? So it'll be 48, choose 3. And then you type that into your calculator and you get an answer, which I'm not waiting for. Okay, the next one says at most 1 black. At most $1 means $1 or less. So at most 1 black means 1 black or no black. However, both of these don't have 5 cards, right? I need a 5 card hand. True statement? So I need 1 black and 4 not black. And in this case, not black is red, but I'm proving the point. And then this one here is 0 black and 5 not black. Now, if you know some things are completely opposite, and in cards, black and red are completely opposite, you could say 1 black, 4 red, correct? Because they're completely opposite. With queens, there's nothing that's completely opposite to a queen, so you'd say 1 queen and 4 not queens, right? But if you have opposites, like black and red, you can do that. So for this one, I have 26 black, and I'm going to choose 1 times 26 red, choose 4, plus 26 black, choose 0. Do I have to show that one? No, I could leave it out, but I could keep it in. It doesn't matter. 26, choose 5. All right, at least 3 spades means 3 spades, 4 spades, or 5 spades, and I have to stop there because that's 5 card hands, right? So I have 3 spades and 2 not spades, or 4 spades and 1 not spade, or 5 spades. How many spades are in a deck? 13. So I do 13, choose 3, and then how many of the 52 are not spades if 13 are spades? 39. So I do 52 minus 13, right? So 39, choose 2, or is a plus sign. 13, choose 4, times 39, choose 1. or 13, choose 5. This one says 1 queen and 3 kings. What's the problem with this one? There's only 4 cards. So the 5th card has to be what? Not a or king. Yeah. So 1 queen, 3 kings, and 1 not queen king. So there are 4 queens. I choose 1. And 4 kings. I choose 3. Now, if there are 4 queens and 4 kings, that's 8 cards that can't be, right? So I do 52 minus 8, which is 44. Choose 1. Remembering that you are putting that into your calculator, correct? This one says how many odd 6-digit numbers are there? Odd means it has to end in an odd number. 6-digit means it can't start with a 0, correct? What about 6-digit codes? Can a code start with a 0? Yeah, a code can be all zeros. Everyone's breaking into your thing, like I always say all the time, but it can start with a 0. Okay? So we have 6. And so if it's 6-digit, this can't be a 0. And it's odd. So this has to be 1, 3, 5, 7, 9. Without repetition means boxing and holding, correct? So I'm going to have 5 options. Pretend I box and hold the 9. Then here I would have 1 to 8, which is 8 options. Pretend I box the 8. Now I've used up the 8 and the 9. What do I have to remember to do for the second blank? I've used up the 8 and I've used up the 9. What's left?
Everything plus a 0.
Everything plus a 0. You have to remember to bring the 0 back. People will tell me it's 1 to 7. It's not 1 to 7. It's actually 0 to 7. It's 8 options. If you don't bring that 0 back in that blank, you will get the wrong answer. It will be there. It's often picked more than the right answer. Because remember, I couldn't use a 0 in the back blank because it would be even. I couldn't use the 0 in the front because it wouldn't be a 6-digit. So I have to remember to bring it back in the second one because I can actually use it now. So say I hold the 0 now, then I would have 1 to 7, which is 7 options. Hold the 1. I'd have 2 to 7, which is 6. Hold the 2. I'd have 3 to 7, which is 5. What do you get when you do that? Anyone get it right? I calculated wrong on. So that was
67,200.
Then this one here, Jeremy, Jesse, Jamie, Amy, Lori, and Crystal go to the movies. Just so you know, that's my 3 brothers and 2 of my sister-in-laws. I had to pick 6 people. I should have just picked all of them and picked myself out. I don't know. I felt like I needed to have myself involved. But I really shouldn't have, right? Okay. How many different ways can they be seated next to each other in the movie theater if there are no other restrictions? There's a blank in there. So how many would be here? 6 then. Why is it going down by 1? Wow, I really gave an extra blank there. Why is it going down by 1 each time? If someone's going to sit down, you're like, hey, you, sit down here, right? And someone sits down. The boys and girls must alternate. You have to watch yourself. So if this is boy, 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 I would have 3 once it's down to 1, and then 3, 2, 1. I know it confuses people because I didn't say Jeremy, Jesse, and Jamie are boys. I know our 2 brothers have kind of girl-boy names. But the first 3 are boys. The last 3 are girls. So 3, 2, 1, 3, 2, 1. And then people tell me that's the answer. But you have to watch yourself when there's an even number. Remember what I tell you have to do? Trust you remember. What do you have to do when there's an even number? We don't go 3 factorial, 3 factorial. We go 3 factorial, 3 factorial times 2. Because we could have this case where we start with boys, or we could start with girls, and it would look different. Why am I putting these? At least I'm not telling you a good weekend like yesterday. That's a win. 3, 2, 1. Which sounds like saying a good weekend is like that's not bad to say, except it was Monday. So that's fine. All right, cool. So we can do this and add them up, Or we could just go 3 factorial times 2, which is, okay, you're going to flip over, get working on the other part. Yep. So for these ones, when you get these pathway questions, remember I told you to treat them like the word dir? So this would be D, 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 and this would be R, 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 R. Now, how many ways can I rearrange that without restrictions? There's 10 letters, so I would get 10 factorial divided by 5 factorial, 5 factorial, and that would represent all the ways this one could happen, correct? Then this one would have D, I picked blue, D, 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 R, 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 right? So this one would actually have 8 letters divided by 5 factorial, 3 factorial for the D's and the R's, correct? Now, do you need these paths and these ones to get you from A to B, or could you just use these or these? Is it and or? And. I also told you if you remember to put like a dot attaching them, that's a hint you multiply. So we would end up having just 10 factorial over 5 factorial, 5 factorial times 8 factorial over 5 factorial, 3 factorial, and then you get your answer. This one we'd have to do 3 of them. So we'd have D, 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 and then 11 R's. So that's 14 letters, so 14 factorial divided by 3 factorial for the D's and 11 factorial for the R's. And then I would multiply it by this one. Oh, cool. Why? Stop. What are you doing? 10. Okay, so then this one would have 5 factorial for all the letters, and then 3 factorial for the 3 D's, 2 factorial for the 2 R's. And then I would multiply that by this one. So this one would be 8 letters, 8 factorial, divided by 2 factorial, 6 factorial. And all of these you will put in your calculator and get an answer, correct? I'm just running out of time, so I'm not finding answers. Tomorrow you will find answers. Do not leave all of these like this. When you do that tomorrow, I'll just be sad. Say you did not listen to me, and then I'll tell you to go to 1758 on this podcast, and like go back to Scooch, and then you'll hear me ranting. Yeah. Yes. This one here says how many 3-digit numbers? 3-digit numbers means 3 blanks. Less than 700 means the first digit has to be less than a 7. So this one says repetition is allowed. So I would have 1, 3, 4, 5, which is 4 options, and I'm allowed to repeat, so I don't box and hold. Then this one I would have 1, 3, 4, 5, 7, 8, 0, which is 7 options, and then I would have 7 again because I'm allowed to repeat, right? So I have less than 700, I just need to make sure that that first digit isn't a 7. So this is 196. Now this one says repetition is not allowed. I still have to start with that first blank because it still can't be above a 7 or a 7, right? But, and it also can't be a 0 because then it would be a 2-digit number, not a 3. So for this one, I'm not allowed to repeat, so I box and hold. So I have 1, 3, 4, 5, which is still 4 options. I'm going to pretend to hold the 5. And I have 1, 3, 4, 7, 8, 0, which is 6 options. Say I hold the 0. And I would have 1, 3, 4, 7, 8, which is 5. 120. I wanted to give to these ones because they're more discussion style questions. So this one says, give me every different way you can describe who you can represent this situation. There are 32 students in Mrs. Lepp's Math 30-2 class. She is randomly choosing 6 of them to go on a trip to 7-Eleven. Does the 6 order in which you pick those 6 matter if they're all going to 7-Eleven? No. So we could say 32 C6, true statement. What does that also equal? Remember C's you can write in such different ways. 32 C what? 26, because you can just subtract them, correct? There's also two other ways you can do it. 32, 6, remember this is C. 32, 26, this is also C. So those are the four ways you can represent it. I'm rushing through this part because it's more discussion stuff. I want you to remember. This one says NCR and NPR. You have seen in this unit, compare the two formulas. NCR just has that extra R factorial in the denominator, correct? If you look at the two formulas over here, NCR has the extra R factorial. It just gets rid of all the cases where the items are actually the same and we were counting them. Remember, it gets rid of the repetitions. Here we have 100 people enter their name into a draw to win 3 prizes. How many ways can 3 prizes be drawn? If all 3 prizes are the same, does the order matter? No. So we would have 100 C3. And in this case, if they're huge numbers, like the n is huge, they often don't actually work it out to an answer. They'll say like ACB, what's A, the sum of A and B. So it would be 103, right? Or they'll ask if it's a perm or a com. 3 prizes are different. If the prizes are different, order matters, correct? So we would have 100 P3, which is a much bigger number. The next one says, a powerhouse committee is being formed from a school division made up of 25 principals, 250 teachers, and 8,000 students, which is actually 8,275 individuals, right? If we put them all together. No restrictions, we have to add them all up. They're wanting to form a subcommittee to discuss issues throughout the school division. They're wanting a 12-person subcommittee. Are there jobs on anything here? No, so it's a combination, correct? So here it says there are no restrictions. So we're not typing these into our calculator, it would get mad at us. So it'd be 8,275, C, 12. Then this one says there must be 2 principals, 3 teachers, and 7 students. And what do I do before I start? I count to make sure that's 12 people, because the subcommittee has to have 12 on it, which that is 12. How do I guarantee principals? From principals. So there are 25 principals, and I choose 2 times. Teachers, there are 250 teachers, and I choose 3. And then there are 8,000 students, and I choose 7. Answer that. I don't know why that just tricked. Anyways, this one says there must be 7 students. Is that 12 people? No, so I need 7 students and 5 what? 5, yeah. 5 not students, so principals and teachers, correct? So I would get 8,000 students, choose 7 times 275 others, choose 5. This one says there must be at most 2 principals. So that's 2 principals or 1 principal or no principals. So I would have 2 principals and 10 others, or 1 principal and 11 others, or 0 principals and 12 of the others. So no principals involved at all. So the principals are 25, and I choose 8,250 others, correct? Oh, whoa, what am I doing? Halt. Go away. I choose 2, times 8,250, choose 10, plus 25, choose 1, times 8,250, choose 11, plus 25, choose 0, which I don't have to write, but I'm writing it for the point. Plus 8,250, choose 12. Then we have 15. Jim decides to line up his cars in the dealership. He has 12 cars. There are 6 black, 3 gray, 3 blue. Different models. What does it change? What does different models do? It just means you don't divide by factorial, correct? The 6 black, I can tell a difference between them. So if I'm just arranging them without saying the first one has to be black, whatever, this one will be 12 factorial. These ones that are identical, it's 12 factorial, but I have to divide by 6 black because they would look the exact same, 3 gray, 3 factorial, and 3 blue. So if they're identical, like identical balloons, remember how I was talking about that, we line up identical balloons? Anything that's identical, you have to divide by factorial to get rid of them because they repeat. Just like the word brood 2 O's would be the same as saying I have 2 orange balloons, right? 1 blue, 1 red. You can always look at them in a word. The last one, a menu consists of 4 appetizers, 5 main course, 6 desserts. I'm choosing appetizers, main course, dessert. Appetizers from appetizers, main course from main course, dessert from dessert. What do I use? C or P? C. Because order doesn't matter. Because I'm picking an appetizer from an appetizer, right? They're the same thing. Order doesn't matter. If I was choosing an appetizer, dessert, and something from a whole bunch of food, then I guess order would matter because whatever it came up as the appetizer would come first, right? That would be different. But if I'm picking principals from principals, students from students, girls from girls, boys from boys, appetizers from appetizers, I've said this many times, drivers from drivers, irons from irons, it's a C when you're choosing from the same thing because the order doesn't matter. So for this one, I would have 4C1 times 5 main courses, choose 1, times 6 desserts, choose 1. This one, I would have 4 appetizers, choose 2, times 5 main course, choose 1, times 6 dessert, choose 2. And that's the fastest way I've ever taught in my entire life. Teached. Yep, and that's why I don't do English. Taught. My goodness. Have a good weekend. Just kidding.